We're here at Snider High School showing an example of masonry restoration, and part of the masonry restoration would also include repairing our precast concrete. We have several of these precast concrete columns at Snider on the north side and also the east side of the building. And this is an example of what happens if we don't stay on top of the repair. We actually have the reinforcing steel that's supposed to be encased with the concrete to protect it has spalled off, and obviously our patches that we've had in the past years are failing as well. This is an example also at Snider. About 3 years ago we had a failure between the window and the column separating from the building, where we actually had to tear down the entire brick column and rebuild it. You can see here with the lighter mortar, when it pulled away from the building, we could actually see through between the window and the building, and snow was flying in. But it's a really good example of a repair that we had to do as an emergency to keep the building operating. Another portion of the masonry restoration is to take care of all of our existing expansion joints. As you can see along the building, about every 40 to 50 feet, depending on the building size, we have these vertical expansion joints that have sealants in them. Part of the project would be to remove all these sealants, clean up the bricks, and install new sealants. What happens with the sealants as they go bad, what can happen is water infiltration in the building, and then also water gets in between the bricks and actually pops them like this. We have several broken bricks because this elasticity of the sealant is gone. This is an example of access and safety. We have existing telescoping bleachers at Northrop, Wayne, and Snider. This is Snider. The reason we have to update the bleachers is because the laws and codes have changed since they originally constructed. Several items where we're not compliant is that we have to have end rails on anything higher than 30 inches. We can't have any gaps in the system. This is an example of the learning environment category of the project. What we see here is 2 interior wood doors. Literally thousands of these in the district, probably 300 or 400 alone here at Snider. Literally thousands of people walk through these doors in any given week. Items that we want to show you, they're obviously just life cycled. The veneer is pulling off. We have 2 different door closures. They've been adjusted several times. The hinges are popped out of the frame. When you open and close them, they're hitting at the top, so it's difficult to have any type of security within the building to maintain security, because you're not positive that the door is shut and locked behind you. So you just have to come back behind you and make sure they're popped tight. This is another example of the interior door. We're actually just adjacent to the ones we just showed you. Same condition. We have 2 different closures even of the closures we just saw. We have shoes missing on the drop rods. We also have veneer missing on these as well. When we were talking about masonry restoration, we were talking about making sure the joints on the outside have proper sealants. This is an example of what can happen when you don't take care of the sealants. We have separation of the block, and we actually have cracks in the masonry, which under the masonry restoration we would repair those as well. This is an example at Snider High School of the existing Terrazzo. Terrazzo is in the corridors at many of our buildings. Great product, and one that we like to restore. To restore the Terrazzo, they come in and they grind out the cracks, add in new Terrazzo, grind, and then repolish the entire floor. We're in the central plant here at Snider High School. We're looking at 9 boilers that were installed in 2005. We would plan on reusing these boilers in the project. There's nothing wrong with the boiler plant. Everything that's attached that goes out to the building, to all the units, that's what we're talking about replacing. These are condensing boilers, the boilers we like to see in every building. They're much more efficient and very easily to maintain. These are the temperature control air compressors that run all of the valves for the temperature controls of our HVAC equipment. These should not run constantly. We've been down here for over 20 minutes and they haven't stopped yet. That indicates that we have several leaks in the tubing that leads out to all the terminal units, which obviously tears up our compressors. We're constantly replacing the compressors. Part of the HVAC project would be to replace the temperature controls with direct digital controls, which are computerized, and we would not have air compressors any longer. We're here at Snider High School down in the pipe tunnels that go underneath the corridors of the building to show you the conditions of our piping. This is a steel heating and cooling pipe that, as you can see, is deteriorating to a point where the wall thickness is gone. And this is actually part of the pipe that has scaled off. This is very typical of most of the piping that runs through all the tunnels under the building. We looked at the steel piping. Now we're looking at some of the copper piping that supplies the hot and cold water to all the classrooms. We have several areas within the system where we've had to add a clamp where we've had a pinhole leak. It's difficult to find the leak, so we have to take all the insulation away and find out where our leak is and then make the repair. This is a repair that had to happen as an emergency just a month ago, where we came down here and water was gushing out of the insulation. So we had to make a repair, but we had to tie eventually into a piece of pipe. This is an example of the heating and cooling system. Try to explain the supply and return piping. Typical situation, you have one heating supply, one heating return, and then one cooling supply and one cooling return. Here at Snider, however, 30 years ago, it was changed out for capacity reasons to actually use two of the pipes as one of the supplies and two of the pipes as one of the returns. So at one point we have heating water going through, and then we have to switch over to cooling, so we have cooling that goes through the piping instead of having a separate two-pipe system, allowing each system to have its own pipes. And the biggest reason for that, the cooling piping needs to have a different type of insulation that will not allow the pipes to condensate. If you use the same type of insulation that you have on heating lines, it allows it to condensate, and then we have deterioration of the piping like we saw earlier, where it's starting to flake off and actually rot from the outside in. This is an example of a science room that, if you look under the column of learning environment, we would replace the countertops and casework in the science labs. They're original. It's science labs here at Northrop, Wayne, and Snider. We have in the past, within the last 5 years, replaced all of the faucets to the units, but we didn't have enough money in the budget to replace the actual casework themselves. Also typical in our science labs, we have hot water and cold water in just some of them. So part of the learning environment, we would recommend that we add hot water to all of our science labs. That would allow more flexibility for the classes that they teach in the curriculum, such as here at Snider with their biomedical program. Under the access and safety column on the program, it would also replace all of our lock sets, the knob type lock sets, with a lever handle lock set to meet ADA. It would also be a lever lock set intruder handle, which would allow during lockdowns, the teacher to actually lock the door from the inside instead of having to walk out of the classroom, lock it from the outside, and then go back in the classroom. This is a typical classroom here at Snider. We want to show you today, under the infrastructure, we have our windows. This is single pane windows, currently right now for air conditioning. In many of our buildings, such as Northrop, Snider, and Wayne, some of the exterior classrooms still do not have air conditioning in the room, so they have to use operable windows. They're single pane, non-thermally broken windows, which unfortunately will allow condensation on the inside. And due to condensation on the inside of the windows and coupled with poor sealants on the outside, we start seeing deterioration along the wall, which we have to continually come in and replace and repair and repaint. The other item under infrastructure will be our univentilator. These are the terminal units we talk about that come off of the supply piping for our chiller and for our heating system. This unit here would be replaced with a new energy efficient univentilator. Under the learning environment, we would go adjacent to the univentilator and actually replace the existing casework, which is houses books and teacher material along with student material. The other item under learning condition would be replacement of Venetian blinds. However, in this room, for example, the Venetian blind is fairly new, so we would simply not put new Venetian blinds in this room. We're here in a boys' restroom here at Snider High School to look at several different items. First, under the infrastructure column, we would replace the in-wall flush valves when we have a leak or repair to it, we actually have to shut down the restroom because we have to bust the block out of the wall and then either put the block back in or put a panel cover over it. The second item under the infrastructure would be to replace the piping within the pipe chases as needed. We would open up every wall and take a look, and if we need to replace the piping, we replace the piping. Under the access and safety, we would do ADA improvements such as the wash fountain, taking that out and making an ADA accessible wash fountain. We would change out the toilet partitions to allow for ADA access. Also, our entrances into most of our restrooms were built before the ADA. So we have a lot of serpentine doorways where it's difficult to get wheelchairs in and out. Under the learning environment, we would replace the toilet partitions. They're starting to rust out. These have doors that have been missing for years, and we would also replace the wood door. We're here at Harrison Hill. This is an example along the west wall where we have masonry restoration needs. One of the issues, obviously, with masonry restoration, if you do not keep up on it, you have interior damage. This is the plaster that we repair, repaint, and the next year we come back and it's all blistered and bubbled back up again. The teachers here at Harrison Hill are really good at covering them up, and that you do not see it, but we want to take care of it correctly, which means we have to have masonry restoration under the infrastructure portion of the project. We're here at Harrison Hill. We're looking at the exterior of that wall, that same classroom we were just in, where you saw the deteriorated plaster. The reason for that is this whole wall needs masonry restoration done to it under the infrastructure column. Part of the masonry restoration will be to remove all of the tuck point joints. The mortar is going to be removed and you tuck point it. You can see here we've had several of the existing mortars popped out of the joints. That all needs to be cleaned up and redone. Another part of the masonry restoration, when you couple it with the window replacement, is all of the lintels above the windows. This one here you can see is starting to rust and delaminate. Those will be scraped down and repainted. And then also above that joint we'll put in through-wall flashing, which will help release some of that water pressure so it exits the building on the outside instead of the inside, which is what it's doing now, and rolling down either side of the window frame and causing the plaster deterioration inside. We're here at Harrison Hill, and they have two additions, one in 57 and the other in 61. And on both of those additions, they utilize the curtain wall cladding for the outside of the building, which is very common of the 20 buildings that are on the proposal. What it entails is basically a cheap and easy, is an efficient at the time way to build a lot of building quick. And it's a infill panel. Essentially, it's a structural system that goes from the sill of the window all the way up to the bottom of the roof deck. It encompasses windows and insulated panels. The insulated panel has metal on the inside and the outside. Due to age, just with the time and being steel, obviously we're starting to see a lot of rusting going on, deterioration. This is all allowing water also to enter the building and cause damage inside. The other item that's poor with the curtain wall design is that it's very thin and very inefficient. So we have to use obviously a lot more utilities to heat or cool a building because of it. Later we'll see an example at Franke Park where we replaced the curtain wall system with a new curtain wall system. However, the differences are it was a precast tilt-up concrete panel, which we also removed about half of the window surface area because you don't need windows from one edge of the classroom all the way to the next edge of the classroom. We went down about 50% inside the classrooms, and that gave us more efficiency on the heating and cooling system. We were able to undersize the equipment because we don't have near the losses through the windows. The other item with the new curtain wall system, it will have new windows and it will have new panels. The new panels will be thicker and have a higher R value. The new windows will be insulated units, thermally broken, which will be a much more efficient system. And we're looking at a typical stairwell. Under the column of access and safety, we would come in here and modify all these stairwell situations so they meet current code. Current code requires that you can't pass anything larger than a 4-inch sphere through the opening. And that's so, obviously, if a child is running through here, like we've had in the past at another school, they can't fall down and slide through. Like I said, in the past, we've had one fall and actually break an arm. So under the access and safety, we would like to take care of all these handrails. We're on the second floor. We're looking on the inside of that large curtain wall that we saw earlier. If we had air conditioning in all of our buildings, we wouldn't have to worry about opening the windows. But as you know, only 37% of our buildings are fully air conditioned, so we have to open our windows. And if you can imagine opening this window thousands of times over the lifespan, we're starting to have quite a few failures just even on the latches on these windows. Such as right here, it's broken off. I had to screw this window shut. So we do have several operable windows in classrooms that we cannot open to allow any cross breeze. We're standing here in the courtyard at Harrison Hill, and we're actually standing on top of the boiler room. Section underneath me is actually the old coal bin. As you can see, we're completely surrounded by building. This was the original 1924 building, and then 1928 they came in and they closed off the rest of it. So this is now the courtyard. The biggest challenges with this courtyard, having the boiler room underneath it, is access. And whenever we need to have anybody come in and work on the boiler room, they can't come in the courtyard because there is no access for getting into the boiler room except for this hatch right here. The only time we use this for access is when we need to replace a pump or a boiler or something very large. We actually have to hire a crane and lift it completely over the second story part of this building from the west side. As we'll show you next, we'll show you some of the other conditions within the boiler room of why we would like to take it out from below grade and take and build a new one above grade. We're at Harrison Hill, and now we're looking at the inside access to the boiler room, which we saw outside that was completely surrounded by that courtyard. If any of our boiler techs or mechanical maintenance individuals need to come in and work on the boilers, they have to go through the school, go actually open up the door to the gym, interrupt the gym physical education class, and then go down another door that will take you down into the boiler room. And we're at grade level right now. The boiler room is about 22 feet below us. We're now at the bottom of the stairwell that leads down to the boiler room here at Harrison Hill. You can tell we're below grade due to the concrete walls. You can see all the deterioration of the concrete because of the water table outside and the water infiltrating the walls. We're now in the boiler room here at Harrison Hill, and this is the old coal bin where we were standing on top of. As you can see, it hasn't rained for a week here, but we still have water infiltration. This is the largest reason why we want to build the boiler room above grade. Boiler room 20 feet below grade doesn't make sense. It deteriorates the equipment that's within the room and obviously causes environmental issues. Here at Harrison Hill, we still have steam heating, one of two we have left in the school district. To provide the steam, we have 4 steam boilers. Because of the conditions of being below grade, the environment is starting to deteriorate the boilers from the outside in. You can see the delamination of the shell. Part of the steam system is we have the distribution piping, which actually is distributed through crawl spaces such as this, which we'll see an example of in a classroom here in a few minutes. We're going to show you the access tunnel from the boiler room that has all the supply and return piping for the steam. To give you an idea, we're in the middle of a classroom. Our techs have to come in and disrupt a class to be able to get in to access the crawl space to make any repairs or to investigate anything with the heating system. This is inside that access panel in the crawl space in the classroom here at Harrison Hill. You can see this is a recent repair we had to have on a steam line. And the reason why, obviously, we're concerned with this, we can only make patches like this to a certain point. Eventually, that steam line is going to be thin enough it'll crush, and we'll be able to make the repair. The crawl spaces actually go from classroom to classroom. We have access points similar to this every other classroom. So there's obviously a lot of space in between the classrooms, and one of the best ways, obviously, to get in the crawl space is to use an old chair as a step stool. We're looking at some casework, which under the learning environment column, this is what we consider casework or cabinetry. It's used to house the sink for any of the kids that they use to wash their hands, but it also stores all the teacher material, and then also in some schools supplies cubbies for the students to put some of their material. Under the plan, if the existing casework was in fine shape, we maybe just refurbish it, and in other cases we would actually replace it. We're here taking a look at a typical classroom that under the learning environment column we would like to replace the flooring. You can see here where we have not had a chance in the several years to replace the flooring. You see several seams that are ripped apart. And this would be under the learning environment. This is a typical classroom here at Harrison Hill. What we're doing here is using a light meter to gauge the light on a desktop. In a classroom, the recommendations are to be at 70. We're in the 40 to high 40s here. What we would do, this would be under the learning conditions column of the project, and we would survey each classroom in this way with a light meter. And if we need it, we have replace the lights. If we don't, we would keep the old lights. Unique to Harrison Hill are 4 bathrooms that are actually raised. So under the access and safety, to take away the ADA barriers, we would have to reconstruct these bathrooms. Other issues with the bathrooms, other than the obvious step up to get into them, to get through the passageway into them, there's a serpentine left and right that aren't wide enough, do not have the proper depths for turning of wheelchairs, etc. We're here at Indian Village and we're in a typical classroom. Renovations were completed here roughly 10 years ago. That's the last full renovation we had a chance to do through our CPF dollars. Here we did a full renovation which include our infrastructure items such as our new unit ventilator, our new heating piping system. However, we did not add a chiller at the time. As you can see by the windows that are open, this would be one of the buildings we would add a chiller to. Some of the other items that were under the infrastructure items were windows. These are new thermally broken, insulated glass units that we would put in all our buildings. The other item under the learning environment would be new flooring and also replacement of the casework. And the casework, again, is where all the student and teacher materials are stored. We're still in the classroom here at Indian Village. Part of the learning environment, we would also replace the ceiling light fixtures as well. As we saw earlier at Harrison Hill, we like to have a recommendation of a minimum of 90-foot candles. And here you can see on the desktop we're anywhere from 103, 106, depending on the time. We're here at Franke Park to show you an example of a curtain wall system. This system was put in place about 3 years ago. We used to have a whole ribbon wall of windows. A curtain wall similar to Harrison Hill from the bottom all the way up to the top was the curtain wall. It was completely removed and over 50% of the old window surface was removed, and we actually put up the precast concrete panels, which will last much longer than a window panel will. And then the other 50% where the windows go, we actually replaced them with thermal insulated units, and then we also use much thicker metal panels as the insulation panels.
The kids and the adults can come into a classroom and feel comfortable, and obviously a comfortable room is a much easier learning environment to sit in than one that is hot with 100-degree temperature, which we had before, or in the wintertime a cold room where the boilers were not working well enough that it could be a 50-degree room. There's just so many things in a renovation that the general public take for granted. It takes someone to come into an actual building and see what everyday education is about. And when they see what some of the buildings, for instance, this building looked like before our renovation versus what it is today, people say, how did we do it? How did we do it? And with the help of the community, we have a place that is a very strong learning environment because of the renovation itself.